Hi folks, welcome to day 1 of chapter 7. We're going to be going through chapter 7.1, polynomials. Alright, so that's going to be how we're starting Algebra C. So we're going to be starting with polynomials, and if you don't know, a polynomial is a function, alright? But it's a function that has multiple terms. Now, that's because here we have poly, which means multiple, right? And then we have nomial, and nomial means terms. So a polynomial is a function with multiple terms, all right? Now, the thing with polynomial is they're super useful. They come up in nature all the time. They come up in math all the time too. We're gonna learn how to add, subtract, and multiply them during lessons this week. But we're gonna start with what they are because we have never heard of these things before. All right. So there are 3 main types. We have monomials. Now, a monomial is one term. All right. Then we have binomials. Think of like a bicycle, right? A bicycle has 2 wheels, and a binomial has 2 terms. All right. And last but not least, we have trinomials. And again, just think of like that tricycle, 3 terms. All right, so those are the 3 main ones, the 3 main types of polynomials that we're going to be working with. All right. Now, what I'm going to do is I'm going to give you an example of each one, and please be patient with me. I am not the best at notability. All right. So let's go ahead and have an example of a monomial. So a monomial can look like 3x, right, because it only has one term. Look like a number. So it can be a number, like a coefficient with a variable, a number and a variable, like we have with 3x. It can be just a number, like 10. It could be a number with a variable to a high power, like 5x to the 4th. Or even something with multiple variables in it, like 3 times x times y squared. That's still considered a monomial because those are all one term. That's all multiplication going on, all right? So those were monomials. With binomials, some of our examples of binomials, we have like 3x plus 2 because there's 2 terms, 5x cubed minus 2x. And again, these terms, they can have variables in it or they could not. Now, the only thing is something like 10 plus 2, right? So if you have like 10 plus 2, that simplifies down to 12. That is not considered a binomial. And then we have trinomials. Right, a trinomial is with 3 terms, so we like 3x squared plus 2x plus 4, right? That's pretty common type of trinomial is with an x squared term, an x term, and a constant or number term. But it could also look at like something like 5x to the 4th plus 3x plus 7, right? Those are also considered trinomials. So now that we have an idea of what polynomials are, let's talk about the 3 main components. All right. Now your 3 main components for polynomials are standard form, degree, and leading coefficient. All right, so those are our 3 main things we're going to be learning today, is how to write something in standard form, how to state its degree, and the leading coefficient. So I'm going to go ahead and start off with standard form. So standard form is the way that we write polynomials. All right, so standard form just means that you're going to take the largest term, the largest power of x, and put it first. All right, so whatever your largest power of x is, that's what's going to go first. So if we had something like negative 6x plus 2x squared minus 7 plus 3x to the fourth, I'm going to look for my largest power of x. So you can see we have x to the nothing, but remember, since there's nothing there, that's an implied 1. So I have x to the 1, x squared, x to the 0, because it's just a 7, and x to the fourth. So we see that the fourth is the biggest one, so we're going to write that first. So we're going to start with, all right, I have a positive 3x to the fourth. And you include the entire term, not just the variable. All right? Then we go in descending order, meaning we go from biggest to smallest. So here we have biggest, all right? I'm looking, since I have x to the fourth, I'm going to look for an x cubed term. Well, I have an x term, an x squared, and an x to the 0. So we have no x cubed term. So if you want, you can always write in a plus 0 x cubed, but to me, I think that's more confusing. But since there's no x cubed term, we'll go ahead and look at our x squareds. Well, we have 1x squared, and it's right here. 1x squared term, I should say. Technically, it's 2x squared. All right, so that's our 2x squared term. Then I'm going to look for just my x. Well, I can see I have a minus 6x. And last but not least, that minus 7, that constant term comes along for the ride. So now we have rewritten our polynomial in the form it was given, and now we have it in standard form. So again, standard form just means put that biggest power of x first, and then go in descending order. Let's go ahead and talk about degree next. So degree is a little different when you're talking about monomials versus other polynomials. So let's go ahead and talk about the degree of monomials first. So when you're trying to find the degree of a monomial, it's just the sum of the exponents. All right, so you're just going to add up all the exponents in your term because you only have one term because it's a monomial. All right, so if my example is something like 3x, well, I have no exponent or an exponent of 0. Oh, I'm going to do that in a different color. I have an exponent of 0 on the 3 and an exponent of 1 with the x. So I'd say degree is 1. All right. That was the easy type, though. All right, that's when we had one constant and one variable. If we had just a constant, right, like if we just had 10, then I have to ask myself, all right, well, that's like what variable is that, right? What's the sum of the exponents on the variables? Well, you can see I don't have a variable here, right? It's just an x by itself. So since there's no x, it's an implied x to the 0, because remember, x to the 0 equals 1, right? That's what we learned in chapter 5 with our exponent rules. So because it's a 0, right, it's x to the 0, we say the degree is 0. So even though there's a term, it's still a degree 0. And the third type of example you might run into is something like 5 times a cubed times b. Now, again, we have our 5, which is a 0 term, or x to the 0. So we have 0 plus 3 plus 1. All right, 0 plus 3 plus 1. 0 plus 3 is 3. 3 plus 1 is 4. So the degree, since we're looking for the sum, the addition of all of these things, the degree is 4. So that's how you do degree of monomials. You're just adding up the exponents on the variables. If there isn't a variable, then the degree is 0. Degree of general polynomials looks a little bit different. So if we're looking at the degree of polynomials, and I know sometimes my handwriting might be a little sloppy, I'm sorry, but my degree of polynomials is actually, I think it's a little bit easier because it's just the degree of the the biggest power of x. So or the biggest term. So it's the degree of the largest term. All right. So I'm going to go ahead and do an example because I think that that's going to help us. So if we have like 5x cubed plus 2x squared plus 3x plus 4. All right. I'm looking for the biggest exponent. So since I'm looking for the biggest exponent, I have x to the 0, so that's not very big. I have an x, a 2, and a 3. So this 3 is my biggest exponent, so I'd say my degree is 3, because I'm looking for the biggest power of x, the largest exponent term. All right. Let's try another example. I have something like 1/3 x cubed times y squared plus 2x to the 4th plus 3x. Now, some of you might be like, oh, well, look, here we have an x to the 4th. That's the biggest one, right? Because here was an x to the 1, and here's an x cubed, so x to the 4th must be our degree, right? But remember, it's the degree of the largest term, all right? So that means that we're not just worried about 1x, right? If we were just worried about 1x, then yeah, the x to the 4th would be the largest degree. But in our case, we're looking for the degree of the largest term. So this one here, we have an x cubed y squared. So that means 3 plus 2, because we have to add our exponents. 3 plus 2 is 5, so our biggest degree is 5. All right. And last but not least, we have leading coefficient. So a leading coefficient is pretty easy. It is just it's the number in front of the largest power of x. All right, so that's all a leading coefficient is. So I'm going to do a quick example. If we have 3x to the 4th minus 2x minus 6x, 2x squared minus 6x, my leading coefficient, I'm going to look for my highest power of x. I have my x fourth. So because of that, my leading coefficient is the number in front. So I'd say leading coefficient is 3. All right. Now with that, go ahead and try out some of the examples I posted in your assignment. And thanks for watching.